Okay, Bismillahirrahmanirrahim. So actually today we will cover a new topic or new chapter, which is the synchronous generator. Okay, or in general is a synchronous machine. Okay, synchronous machine. And yeah, synchronous machine divided into two things. One is the generator and the other one is the synchronous motor. Okay, so generator actually is very quite simple, and actually we cover for 2 weeks. Okay, yeah, actually we can compress everything in 1 week, but it's okay, we separate it for your batch. We still separate because this is a very short topic. Okay, so really hope that everybody can understand understand the synchronous generator yeah, easily, because it's quite easy. This is quite easy. Okay, so this is the outline of the chapter. So in today we will cover up to 6 the point 6, power and torque in the synchronous generator. So the other two involve calculation. So yeah, next week we will do the calculation, inshallah. Okay, so as usual, this is the video for the induction for the in the teaching and learning method they call this as induction. Okay, so later on please watch this video. So unfortunately I can show you here because it's lag. Okay, so what is the synchronous machine? Okay, what is the synchronous machine? So what do you understand about synchronize? Okay, so normally we found the synchronize in our phone, where we want to sync our data to the cloud. Okay, sync. Okay, so anybody can share what do you understand about synchronize?
We can insert our data to the specific thing that we want.
Okay, so sync in another way we can say that is do a parallel thing. Okay, syncing, do the same thing. Okay, here we have, for example, in your phone you have, in the cloud also you have, so both have the same thing. Okay, so in motor, so in short we can say that yeah, we learn about the rotating magnetic field. So the rotating magnetic field and the rotor is moving at the same synchronized motion. Okay, so to provide the magnetic field, so since this is a generator, so generator generate electrical, okay, and is from the mechanical movement, mechanical rotation, and then it will convert to the electrical. So in order to generate the electrical signal, electrical power, so that first we must have the magnetic field. Okay, so in order to generate the magnetic field at first, so we must supply. So we must supply the DC. We must supply the DC current. Okay, we supply DC current to the rotor. Then once the DC current is applied to the rotor, so they will produce a magnetic field. Okay, so you can see here there's a rotating rotor, so rotor will produce magnetic field. Okay, B, this is B in this direction, for example. Okay, so and this B is rotating. Okay, this B is rotate together with the rotor. Okay, rotor is turned by a prime mover. Okay, by a prime mover, maybe a turbine or wind turbine or something lah. And this rotating magnetic field induce a three-phase voltage. Okay, so at stator part they will induce the E induce a three-phase voltage. Okay, within the stator winding. Okay, so there is two terms described by the winding. So first is the field winding, where the field winding is produce a magnetic field. Okay, produce the magnetic field, which is at this synchronous generator is at the rotor. Magnetic field is produced at the rotor. And the other term is the armature winding, where the place voltage is induced. Okay, so at this point the voltage is induced at the stator. Okay, so yeah, the other name for the synchronous generator also sometimes they call it as a alternator. Okay, so as I mentioned, they convert the mechanical power, okay, with the rotating movement, okay, to the AC electrical power. Okay, the field winding at the rotor. Okay, so winding that produce the main magnetic field in the machine, and the armature winding is at the stator. So winding where the main voltage is induced. There are two types of rotor. So there are two types of rotor. One is the salient pole. Okay, where there is a looping coil. Okay, this is a looping coil. So the looping coil. So they looping banyak kali lah. Okay, few times. And then this is a pole lah. Okay, this is a pole. So where the pole will produce the magnetic field. Okay. And then there is a non-salient pole or a cylindrical rotor. Okay, it's look look like a cylinder where the coil is at the slot, the few slot over here. Okay, so quite easy to differentiate. Okay, because you can see the pole is like a bump over here. Ada bump sini, so ada bump. Kita boleh bezakan, you can differentiate salient pole and non-salient pole. Okay. Okay, so how to produce or inject or supply the DC power? Okay, so there are two approaches to supply the DC power. So one is by the external DC source, by using a slip ring. So by using a slip ring like this, this is quite similar like a DC motor. Okay, so yeah, so this is the shaft. Okay, this is a rotor shaft. Okay, ini rotor shaft. Okay, and then ada pole tadi, ada pole. Okay, so and this is not moving moving. This is a slip ring. So slip ring is attached with the rotor. So the carbon brush will press here, and this will supply the positive, and this is negative, and this will will connect to the pole lah. Okay, this one will connect, and then the DC current will flow to the pole. Okay. Okay, so boleh imagine Can you imagine about this? So this point, this yellow one, they call it a slip ring, and this one is called as a carbon brush. Okay, so it's a metal ring. Okay, a circle, a shaft is a machine but isolated from it. Okay, so they separate lah. Dekat sana ni satu kat lagi kat sini. Okay. Okay, and the second approach is the special DC power source. Okay, so there are few ways. So even though they supply a DC power, however, it comes from the AC. Okay. Okay, so there's a conversion. They use a rectifier, and then they become a DC. Okay. So this one is special DC power source mounted directly on the shaft. Okay. This is also known as an exciter, which consists of 3-phase AC circuit. Okay. That rectify to the DC source. Okay. They supply AC. Okay. And then they rectify it and then become a DC source. Okay. So by using a 3-phase rectifier circuit. Okay, so this is a exciter or brushless exciter to replace the duty of slip ring. So this one, no slip ring. No slip ring. Okay, so this is improvement, the improvement, because by using a slip ring, so for long term, maybe the DC supply will be reduced, okay, due to carbon is tear the house, the tear kan. So the house, so ni dia dah not connected. Okay, at long term, maybe this the force or the connection between brush and slip ring will reduce the connection. So maybe dah ada gap. So once dah ada gap, so dia punya supply tak okay lah. Okay, supply is not that good lah. So to improve, they use a special DC power source. Okay, where is there no slip ring. So how to see when there is no slip ring? So how? So this is the figure. You look at this figure. So this is the rotor part. Okay, the upper side is the rotor part, and the below one is the stator part. Please be reminded that the output, okay, the output is always at the stator, because this is generator. The output is always at the generator. So this is the output. Okay, 3-phase output. Okay, this is the output. However, in this case, the input also from the stator. Okay, so when we use the slip ring brush, so the directly connect to here, connectly to the rotor. Okay, however, the special DC power source they use or they generate from the stator. Okay, so at the stator they supply a 3-phase input, low current. So this is to generate a magnetic field. Okay. So when there is a magnetic field, so they call it as a exciter field. Okay, exciter field. So they will generate a magnetic field. So when there is a magnetic field, and then the rotor moving. So once there is a magnetic field, and then there is a moving coil. Okay, so the current will induce, or the voltage will be induced. Okay, once the voltage is induced, so over here the voltage will be induced. So ada current. So once current induced, dia ada current. Okay, so 3-phase current. Okay, there are 3-phase voltage, and then they rectify. Okay, rectify become DC. Okay, become DC. Okay, so when they become DC, so they become a magnetic field. Okay. Okay, they will produce a magnetic field. So once they produce a magnetic field here, so at the stator coil, okay, so they will induce a voltage. Okay, so at this point, even though there is a generator, we must supply the power. Okay, we must supply the power. Okay, ni power supply okay, at low voltage. Okay, so and then there is another one. Wait, I share to you. So if you have this book, kindly you can open this book. This is a very good book. It's a textbook. So I just want to share to you the generator generate the magnetic field without using a power supply. So that is very interesting. Okay, so this is just now we look at this one, and there is another one at this point. Okay, this is very interesting. So you look at this. Okay, so at this one, so from here you can see there is no power supply. Okay, there is no power supply at the stator, and also there is no power supply to the rotor to generate the magnetic field. However, they used how to generate the magnetic field. The first magnetic field, actually they use the permanent magnet. Okay, at first they use a permanent magnet. Okay, so when there is a permanent magnet, of course there is a magnetic field. Okay, so when there is a magnetic field and the rotor is moving, okay, and then they cut through the over here the first coil at the stator. Okay, so this will induce a power, okay, voltage, and then induce a current, three-phase current, and then they will generate a field, magnetic field again. Okay, so they will generate a magnetic field. So rotor is moving, and then this will induce. Okay, they will induce again. Okay, and then they will rectify to the DC supply, DC power lah, DC power. Okay, so when there is a DC power or DC current, so they will produce a magnetic field. Okay, so when there is a magnetic field here, so they cut through the coil, the main armature, and then they will produce a output of the generator. Okay, so this is interesting. So they need to design the suitable magnetic permanent magnet, and then the excitation. This is the excitation circuit. Okay, excitation circuit, and this is also the excitation circuit over here. Okay, so yeah, very interesting. Okay, yeah, motor to move, they use the prime mover over here. Okay, so by turbine or something. Okay, so we go back to the slide. Okay, understand for now?
Okay, doctor.
Okay, so you can imagine, so this is the generator. Yeah, in the industry, this is very big. So yeah, this is the exciter. Yeah, maybe they use outside power supply, and then to generate the DC supply. Okay, so this is type of slip ring. So this is the slip ring, and this is DC brush. Okay, so they contact each other. Okay, so the problem sometimes when using a DC brush, the brush one, sometimes when you touch, so the brush macam ada apa, oxidation. So the contact is got problem ada problem dengan contact dia. So sometimes kalau you tengok ada DC motor kan, you ada motor tak mula-mula you beli dia laju, tapi bila dah lama-lama guna dia jadi macam agak slow. Okay, so sometimes because dia punya contact so that's why you need to buy they call it contact cleaner. So actually to remove the dirt, the carbon. Okay, as you can see from the slide, I also include the link for the YouTube link, so that you can study more in detail about this topic. Okay, so I try to simplify everything, and inshallah you can also understand. Okay, synchronize, the meaning that the electrical frequency produced is locked. Okay, so which means they're moving together. Once they lock, they will move together. Okay, or synchronize with the mechanical rate of rotation. Okay, so from here you can see the electrical frequency with the mechanical rate of rotation. So still remember the N sync equal to 120 Fe over P n. Okay, so at this point we don't have this, we don't have the electrical frequency, we don't have, because it's generated later. Okay, so what we have is the movement. Okay, so this is the N sync, so this is not suitable at this point. Okay, but the equation is quite similar. Okay, so what we have here is the rotation of the motor or the rotor. Okay, so we just rearrange. Oh, Allahu Akbar. We just rearrange and then we can get the equation. So the electrical frequency equal to rotation of the motor. Okay, this is RPM, number of pole. Okay, so this is electrical frequency. Okay, electrical frequency. So the rate of rotation of the magnetic field is related to the stator electrical frequency. So it's very related. So from here you can see that the frequency is in hertz. Okay, so whatever in hertz mean that for example 10 hertz mean 10 sample in a second. In a second. Okay, so kalau RPM, so the revolution per minute, so in 1 minute. Okay, so this is in hertz, so kena faham benda tu. So this is the mechanical, is RPM. Okay, so okay, now try to imagine. So to generate 50 or 60 hertz, to generate 50 or 60 hertz, so the generator must turn at fixed speed. Okay, the generator must turn at fixed speed depending on the number of pole on the machine. Okay, so kita kena ingat so we need to remember that we want to generate a power based on the frequency. Okay, so frequency also we need to consider. Okay, so since we have this equation, the relationship, so we need to move the rotor until we reach this these two. Okay, these two frequency. Okay, so please be remember. So this is important. Okay, so kalau for example so if we have two pole. Okay, for example we have two pole, we want to generate 60 hertz. So what is the Nm? Boleh calculate? So we need to move until 3600 RPM. So then we can get this frequency. Okay, so tu dia punya syarat dia lah. Okay, boleh faham kan ni? Ni still awal lagi ni. So yeah, this is the general understanding, general knowledge about the pole. So we have a silent pole and also the cylindrical pole, silent rotor Okay, so this one is using for the low speed application, so less than 3000 rpm. Okay, so which require large number, okay, large number of pole. For example, just now, okay, just now we just have 2 pole. So if 2 pole, we need to rotate very high speed. Okay, so if low speed, so we need to calculate lah. So as a engineer, we need to design what is the suitable number of pole, what is the suitable rotation speed, and so on lah. So if you want to generate the energy from the hydro turbine, so you need to see the flow, and then you can design. Okay, so and then the cylindrical rotor are used for the high speed application. So this is a gas steam. Okay, so minimum number is 2. So why 2? Siapa boleh, why 2? Why minimum number is 2, not 1? Boleh beritahu tak kenapa 2? Hello? Okay, sebab motor kan bulat. So bila ada 2 pole, so baru dia jadi kiri kanan. Okay, so baru dia jadi kiri kanan. So bila kiri kanan, dia ada north and south lah. Okay, so barulah jadi. Kalau 1 pole macam mana? Okay, so ni katakan ni adalah stator kan. Ni stator. So ni dalam ni rotor kan. Ni rotor. So rotor ni pole. So ada 2 pole macam ni lah. Okay, so kalau 1 je, you boleh imagine lah motor jadi apa macam mana kan. So boleh jadi dia tak stable pun satu hal juga. Okay, so there are 2 types of speed, when no load speed and also the rated speed. Okay, so no load speed, which mean that for example like this, you have a motor, you have a blade, and then you just turn on. Okay, you turn on saja. Once you turn on, so the system or the machine will rotate. Okay, so nothing will touch to the blade here, nothing. However, once you put some load, okay, they call as a fully loaded. Okay, so of course the no load speed is higher than the rated speed. The no load speed is higher than the rated speed lah. Okay, of course lah. Okay, kalau terbalik memang you design something yang luar biasa lah. Okay, so rated mean that you design system tu memang at full load dia akan jadi macam ni. Okay, so rated speed boleh katakan lain adalah design speed ataupun design punya sistem, design punya situation. Okay, what they call it as a rated speed. Okay, okay, so this is a magnetic. So we come to the new subtopic, which is the internal generated voltage of of a synchronous generator. So internal generator, you pun dah tengok kan sebelum ni yang ada EA kan dekat induction motor. It's quite similar. Okay, however, in order to come to this point, okay, we must learn about the fundamental, how we get this equation. Okay, so this is the voltage and magnitude induced in the stator phase. Okay, however, this is come from where? This equation. So let's open the book. I'm not sure which page. Forget lah. 173. Okay. actually it's come from here. So kalau you tak ada buku ni, you boleh saya dah upload lah, if I'm not mistaken. Okay, so yeah, okay, this is the best page. Okay. Okay, first of all, please imagine that we have a one coil. Okay, so this is a one coil. Okay, ada satu coil yang rotate lah. Okay, so at this point we supply DC power. Okay, so bila kita supply DC power, dia akan generate silap. Ini adalah stator. Ini adalah stator. So this is at the stator. So at the rotor, yeah, of course we know that we supply the DC power, and the DC power will generate the magnetic field. Okay, so we assume that the magnetic field is in this direction, in upward direction. Okay, so where this point, okay, this is actually at this point, dua ni boleh nampak kan kat sini kan. Okay, so saya padam dulu. Okay, so you imagine lah dekat sini dia ada dua ni kat sini. So dia ada AB and then DC. So AB DC boleh tengok So the rotor will produce a magnetic field. Okay, so in this direction, for example at this direction, so at this direction actually is the maximum. Okay, so the maximum magnetic field. Okay, the magnetic field, and also the current will be induced at this point is very high. Is the maximum. Okay, so kalau kalau motor tu dah rotate, dia dah dekat sini. So when the B is here, so there is an angle. So dah ada angle, so dia akan berkurang. Okay, so once they reach the 90 degree, okay, katakanlah this is B, so the angle is 90 degree. So at this point, the induced voltage is very low, and not very low, it's zero. Okay, so zero. So for example sini B, kalau angle zero, maximum. Okay, and then B, angle 90 degree, output will be zero. So from here we can see that this is the cosine punya function. Okay, cosine. So therefore dia punya signal yang terhasil adalah cosine. Okay, so since they rotate, so since the magnetic field is depend on the speed, okay, the angular velocity, so kita kena letakkan sekali so B equal to Bm, so cos actually theta minus the angle, so this is A. Okay, and then this one theta, since they dependent on the speed, so will become Bm cos omega t minus alpha. Okay, so once we put a 90 degree here, so they will become zero. Okay, so at this point, so kita tengok, wait, saya padam sekejap. Ini kita tengok dekat sini So at this point ni CD ni, point CD ni, so kita pun dah tengok tentang relative motion. Okay, so kita tengok coil ni, kita ambil kita lukis balik kat sini kita lukis balik. So kita lukis kat sini balik. Okay, so dia punya magnetic field is in this direction. This is B, and the angular velocity is moving at this position. Okay, so when we look at the relative motion, okay, so when we look at the relative motion, the v will move to the not move, but the relative motion is at this direction. Okay, v relative. Okay, so then by using our right hand rule, okay, so right hand rule, and then the current will flow to which direction? Inside the paper or outside the paper? Siapa boleh beritahu ni? Amma mana Amma?
Ya betul.
Amma.
Ada.
So by using a right hand rule macam mana? Outside ataupun inside? Dia akan jadi macam ni atau dia akan jadi macam ni? Mana satu? Tak ada orang boleh jawab ni.
Inside kot.
Inside kot?
Ikut.
By using a right hand rule. Right hand. Kan kita dah belajar sebelum ni. Right hand. V mana, B mana, I mana? Siti Nur Ain. Mana? Siti Nur Ain.
Yes. Outside.
Outside. Okay. So yeah, dia akan outside lah. Sebenarnya dah ada dah gambar kat sini. Nampak ni. Dia point out kan. Okay. Dia akan move to the, dia keluar daripada paper. Outside the paper. Okay. So dia flow at this direction. So kalau kat sini, kita boleh nampak dia akan flow at this direction lah. Okay. Betul? So once kita boleh tahu satu direction belah sini, so yang lain pun kita boleh agak lah. Dia akan rotate macam ni. Dia akan current flow macam ni. Okay. So ini dia akan current, dia akan produce lah. Sebab dia generator kan. So that's why current akan keluar daripada positif. Okay. Ni akan dia masuk macam ni lah. Okay. So tapi dekat bawah, so bila kita tengok dekat bawah kan, so since DC punya voltage tu, DC punya magnetic field, dia akan kat semua kan, semua bahagian macam tu. Okay, bawah pun sama, dia akan tolak ke bawah juga. Kita boleh perhatikan macam tu. Okay, so kita ambil yang bawah pun sama. So magnetic field ke bawah, and then movement velocity ke sana, ke kanan. Okay, relative motion ataupun relative velocity ke kiri. Okay, so by using a right hand rule, dia akan pergi mana? Amam Mujahid, dia akan pergi mana?
Outside.
Dia akan outside the page, betul? So dia akan outside the page. Okay, ini by using our right hand rule lah. Tapi apakah kita make assumption ni betul? Okay, so kalau dia tulis kat sini kan, nampak, tadi kita dah buat macam ni kan. So bila kita dah buat macam ni, bermaksud yang sebenarnya adalah ke dalam. Okay, dia adalah into the page. Okay, not outside the page. But from here actually we can see that the current is outside the page. Okay, but at this point we can see actually the current is into the page. Okay, so kita boleh nampak ada confusion kat situ kan. Okay, so in order to solve the problem, okay, so we just change the direction. Okay, so in order to change this direction, okay, we just put some negative signal, negative negative punya sign. Okay, okay, at this, okay, over here, okay, this one kan, so kita boleh guna this one. Okay, so this is B, C, D kan. So kalau B, bawah tadi apa? AB, BAB. So in order to solve the contradiction outside and inside, okay, we just put some negative over here. So BM cos omega t minus alpha. Okay, at this point the alpha is, okay, seen over here kan, so alpha is 0. Okay, this is alpha 0, and at AB alpha is 180. Okay, so BCD equal to BM cos omega t. BAB equal to BM negative cos omega t minus 180. Okay, so kita dah ada dua ni kan. So kita dah ada dua ni. So kenapa kita nak ambil bawah CD dengan ni? Sebab dia flow. Sebab ni sebab dia ada current flow ni. Okay, so lagi satu penjelasan yang kita boleh jelaskan kat sini adalah bila dia move ke atas, magnetic field move to from rotor, okay, this is rotor to stator, okay, rotor to stator, so this is become north pole, okay, and this one of course will be south pole, okay, so dia punya movement sepatutnya macam ni lah, okay, dia punya circulation dia. So ni this direction, because dia north pole, and bawah mesti south pole lah. Okay, so therefore the direction tadi tu we just put the negative sign, okay, over here. Okay, this is important lah. Okay, so then we know that ini saya dah jelaskan tadi. So tentang yang cross tadi tu kan, so dia punya tu, so kita dah tengok tadi VBL tadi kan. So kalau tadi tu hanya B saja, so V kita ganti kat sini lah. Okay, so VBL, okay, ni yang dekat BA. So dia ada 4 segmen kan dekat sini. So ada segmen AB, BC, CD, okay, dia ada 4 segmen, 3 segmen, okay. So ada segmen AB, so kita ada tengok tadi lah. So kita dah ada, kita just darab B tadi kan. So VB ni kita dah ada negatif tadi kan. So kita just letakkan je. Okay. And then kalau segmen 2 tu, bila dia cross product, dia akan dapat 0. Okay. Sebab dia same direction kan. So tak ada lah. And then segmen CD pun sama lah. So ni yang tadi dekat DC tu, dia alpha kosong kan. Okay. So alpha kosong dia akan dapat equation seperti ni lah. So DA dia akan dapat kosong lah. Kemudian yang total voltage induced adalah EA tambah DC, EBA, EDC. So kita letakkan je lah yang tadi ada negatif tadi. Okay, VBL this ni dengan this equation lah. Okay. So untuk kalau kita gunakan trigonometry trigonometry kita gantikan cos theta is actually equal to negative cos theta minus 180. Okay. So now they become VBM L cos theta omega T. So dua-dua ni sama. So dia akan jadi 2 VBM L cos omega T. Okay. So then kita tengok L ni kita tengok ni V. V actually is equal to R omega. Okay. So then kita gantikan lah R omega ni. So kita gantikan R omega di sini. Okay. So sekarang kita ada 2RL. Okay, 2RL. Okay, 2RL ni stand for apa? Okay. So kalau kita tengok balik kat sini so ini adalah L. Okay. Sekejap saya tukar color. Saya ambil warna biru ni Okay, so this is L. Okay, so this is L and this is R. Okay, and once we have a 2R, this is RR, so we have 2R. So 2R, sama dengan diameter, betul? So bila diameter, so this length dl is equal to what?
Area.
Yes, pandai lah. So dia akan jadi area lah. So dia akan jadi area sini. This area Okay. So dia jadi area. So area dia akan gantikan dengan, so kalau kita tengok kat sini 2RL. 2RL ni akan jadi A BM lah. Omega cos omega MT. So AB ni kita boleh gantikan apa? BA. BA tu sama dengan BA is equal to what? BA is equal to flux. Okay, masih ingat tak? So kita pun tukarkan BA tu jadi flux. Okay, so dia jadilah flux omega M cos omega MT. Okay, so this is the total induced for a one coil. Okay, so kita ada few coils. Okay, so kita ada few coils, dia tambah lah, dia darab je lah. Okay, so dia darabkan dengan NC tadi tu. Okay, so tapi macam mana boleh dapat yang ni kan, boleh dapat equation macam ni. Okay, so ini actually dia datang daripada sama juga, cuma dia pecahkan omega ni. Okay, so omega is equal to 2 pi f. Okay, so gantikanlah NC pi 2 pi f cos omega t. Okay, so and then this is the E induced. So what they want actually is the RMS value. So dia akan perlukan RMS value. Okay, so ni yang tadi tu dah ada F tadi. So therefore the RMS value, the RMS voltage, okay, just divide je lah dengan power of 2, root 2, divide by root 2. So they become this equation. Okay, so this equation is what we are using here. Okay, boleh nampak tak dia punya flow?
Boleh, Doktor.
Boleh so it's okay. Later on you can see the other videos that I shared already. Okay, I include in the slide. Yeah, later on you can re-look again at the video, then you can get more understanding. Okay, so this voltage is apparently depend on the flux. Okay, kita pun dah sebut dia depend on the flux. Okay, and then also the frequency and also the speed of rotation. Okay, so semua sekali dia bergantung. So kenapa dia ambil depan ni saja? Kenapa belakang tadi tak ambil? Where is the cos omega t? So this is the magnitude. Okay, so this is the magnitude. Kena ingat magnitude. So in simpler form, they will just reduce at this point. Okay, okay, dia gantikan sajalah ni. Okay, where k is the constant of representing the construction of the machine. So later on you can try okay, how to simplify from here to here. So you boleh balik 2 pi f equal to omega. So omega nanti divide by berapa, divide by 2 ke apa semua sekali, then you dapat gantikan lah. Okay, so you can see over here the relationship between the flux, the IF, and also the EA. So this is the relationship flux to the IF. Okay, so the more the IF, the more the flux. Okay, until some point they will become a saturation. Okay, until some point they become saturation. Okay, So the other name of this graph actually is a magnetization curve. Still remember the magnetization curve? Okay, and if I'm not mistaken, there's also another name. Okay, so this is, so since EA, so EA is proportional to the flux. Okay, so they will be the same. Okay, so kalau IF naik, EA pun akan naik. Okay, so this is the magnetizing curve or the open circuit character. Okay, open circuit characteristic if I'm not mistaken. Okay, so the OCC. Okay, so in simpler form, so kita pun dah tengok ni. So this is the equivalent circuit. So equivalent circuit, simply in simple way we can okay, sekejap sebelum we go here, better we look at the book first. Okay, ada yang dah download belum buku ni?
Dah doktor.
Ya, buku ni of course dia akan lebih detail lah, so kita tak cover lah semua kan. Mana dah? Oh, dia pergi ke ni. Okay, so in order to get the equivalent circuit, so in order to get the equivalent circuit, we need to look into a detail, the effect, the effect of the surrounding. Okay. Okay, so here you can see here. So in order to design, okay, so we need to see at the relation between the EA and also the output. Okay, so EA is the internal generated, okay, internal generated voltage. Okay, so you say that EA is not usually the voltage that appear at the terminal. Okay, so bila kita put the measure the current, measure the voltage at the output of the generator, normally we will not get the EA, okay, EA value. Okay, so sometimes we can get, but in open circuit condition. Okay, so in fact that the only time internal voltage EA is the same output to the V phase. Okay, is when there is no armature current flowing. So ni kita boleh lukis macam ni lah. So for example ni EA. Okay, and then this is the V phase. Negative. So this is V phase lah. So bila kita letak multimeter sini, kita tak dapat pun. Susah nak dapat EA equal to V phase. So memang kita tak dapat macam ni. Memang biasanya kita tak dapat. Okay. Okay, this is due to some because dia ada voltage drop. Okay, so ada voltage drop. So why the voltage is drop? Okay, so dia tanya kat sini, why is the output voltage from the phase not equal to the EA, and what is the relationship between the two voltage? Okay, so kita nak tengok kita kena tengok apa model. So dalam kita nak tengok ni, kita boleh generate nanti model dia, efek-efek dia kan. So the first point adalah because of the distortion of the air gap magnetic field by the current flowing in the stator. Okay, so dekat stator tu dia ada air gap, okay, and magnetic field. Okay, so this is called as a armature reaction lah. Okay, so dekat ni stator, ni rotor. Okay, rotor. Alamak. Okay, rotor, and then hilang juga. La ilaha illallah. And then ada stator. So dia ada air gap lah. So ada air gap. So kat sini dah ada satu isu lah. So dekat sini dia akan, rotor will generate a magnetic field. Okay. And once the stator induce a voltage, so okay, they induce voltage. Once they induce voltage, they will induce a current. So the current flow into the coil will produce a magnetic field. Okay. So they will have a armature reaction. So seolah-olah macam sini ada produce, lepas tu sini pun produce. So dia macam ada interception lah. Okay. So therefore dia akan effect kepada net magnetic field net yang total punya lah, total magnetic field akan effect, okay, because of reaction lah. So stator juga akan produce, rotor pun akan produce. So bila dua-dua produce, dia akan macam interact each other lah, macam dia akan subtract each other lah. Mana satu yang lebih kuat, dia akan dominan lah. So, tapi dia akan berkurangan lah, macam tu. So kemudian the armature coil, so the self induction. Okay, so dekat armature coil tu, armature is at the stator. So once the current dah flow, so dia ada armature inductions. Okay, and then juga dekat coil, armature coil tu dia akan ada resistance. Okay, and also the effect of the salient pole rotor shape. So yang ni kita ignore lah. Yang ni at this class we ignore at this point lah. So kita ambil 3 ni je. 1, 2, 3. Okay, to design So design dia ni lah. Nak design dia punya circuit. Okay. So in short, okay, secara ringkas, kenapa tadi kita measure? So why we measure here V phase is less than EA kan? So actually it's because of the effect of the ada reaction, armature reaction. Okay. So armature reaction tu kita boleh nampak dekat sini lah sebenarnya, dekat buku ni. Okay, yang macam ni lah senang. Okay. So ini dia punya stator. Boleh nampak tak sini? Boleh zoom tu.
Nampak juga, boleh lah.
Okay, so yang ni pun. Oh, nampak. Okay, so this is the stator. Ni stator ni rotor, silap. Ni rotor, ni stator. Okay, so rotor we know that they will produce a magnetic field, okay, through the DC supply tadi kan. DC, they will produce a internal voltage, okay, internal generated voltage, okay. And then once the induce a voltage, they will induce a current, okay. Once we put the lagging voltage, lagging load, they will induce a lagging load, lagging current lah. Okay, lagging current. So that's why dia ada gap sikit lah, ada gap, ada angle kan. So they will produce a current. So once dah ada current dekat stator, so current akan produce magnetic field. Okay, so BS. So BR is the rotor, B rotor, and BS is B stator. Okay, so ada B stator. So B stator ni, so B stator pun dia akan produce juga. Dia akan produce magnetic field. So bila dia akan produce magnetic field, dia akan also induce a voltage di stator. Okay, so dia akan produce E stat. Nampak E stator ni. Okay, so E max plus dengan E stator ni. Okay, so therefore bila dia ada dua magnetic field ni, so secara total ni dia akan hasilkan B net lah. B net. So B net is equal to BR plus BS. Okay, where V phase is equal to EA plus E stat, E stator lah. atau voltage di stator. Okay. So you can see here, if the X is constant and proportionally, then the armature reaction voltage can be expressed as, at this point, so E stator. Okay. So E stator is equivalent to negative J X IA. Okay. So boleh tengok kat sini lah. So therefore dia punya equation ni kat sini. Okay. So this is E stator. Negative J X IA. Okay. So kalau kita buat Kirchhoff voltage law, so kita akan dapat equation ni lah. Okay. So V phase is the output of the synchronous generator. EA is the internal generated or induced voltage, and X is a constant due to the armature reaction. Okay. And then IA is the armature current. Okay. Tapi apakah itu saja? Tadi kan kita dah tengok kan, yang ada lain kan. So kita ada self inductance dan juga resistance. Okay. So since dia ada self inductance dan juga resistance, so kita kena include juga di dalam equation. So memandangkan V phase tu akan lebih rendah, so dia akan tolak jugalah. Okay. So this is the self inductance tadi tu. Self inductance, and this is the resistance tadi lah. Okay. Ni R ni adalah resistance lah. So ni adalah self inductance. Okay. So we can simplify nampak ada IA. Okay. So ataupun yang ni kita boleh simplifikan kedua ni. So ni adalah armature reaction, X adalah armature reaction. Okay, reaction, and XA adalah self inductance. Self reactance lah kalau dia dah panggil tu. Okay. So kita boleh gabungkan kedua-dua ni. Okay. So kedua-dua ni kita boleh gabungkan. So they will become synchronous reaction. They call it as a synchronous reaction. Okay. So once bila dah ada synchronous reaction, dia punya equation pun become lebih simpler lah. Okay. So I think this equation similar to the previous study lah. Kita pun dah tengok ada induction motor. Okay. Kita pun dah tengok juga tentang transformer kan. So dia quite similar to the previous equation. Sorry dia tak tergabung, dia tergabung sikit ni. Okay, so this is the three phase Kalau you boleh imagine three phase punya circuit. Okay. So ni yang kita supply tadi tu, V supply DC, so dia akan produce field current. Okay. Bila ada field current, dia akan ada flux dia akan generate EA lah. Okay. So EA ni akan phase 1, ni phase 2, ni phase 3. Okay. Tapi dia punya circuit sama je lah, semua equivalent circuit dia sama je. So dia ada synchronous reactance dan juga resistance lah. Okay. Okay, so this is type of connection. So we have Y connection, and also we have the delta connection. Okay, so this is very important. This connection. Okay, because in the exam normally we ask the calculation. So the calculation for V phase pula, calculation for delta and Y connection a little bit different. Okay, so untuk VT actually is equal to the this one power of 3 V phase. So normally in the test in the question they give the VT is given and V phase we need to calculate. Okay. Okay, same goes to here. So this is bila delta dia lebih mudah, tapi kena ingat I dia pula berbeza. Okay. So how about IL? How? Okay. So this one is IA equal to IL. And this one how? Ni you kena cari ni saya nak you cari. Macam mana dia punya relationship. Okay. So this is the phasor diagram. So phasor diagram of the synchronous generator. So yeah, we know that EA, once there is a load, when there is a load, V phase, okay, normally V phase is less than EA. Okay, so when V phase is less than EA, you can look over here, the phasor diagram also effect. So nampak ni, the V phase is more shorter compared to the EA. Okay, so over here we can see that the IA actually is in phase with the V phase. Okay, so here is V phase is the reference, so they become 0. So now over here we can see that IA phase also become 0. The phase of IA become 0. So this means that the PF is actually unity. Okay, so this is the phasor diagram when the power factor is 1. Okay, so 1, so macam ni kita nak tengok ni kan. So ni length of IA tu, IA, so IA plus multiple with IR, IA multiple with R. Okay, and then the reactance normally will lead at 90 degree. So ni 90 degree. Okay, always 90 degree with the resistance. Okay, and then 90 degree, and then kita tegakkan sini lah. So and then kita boleh jadi dia trigo. Okay, so dia akan jadi tegakkan dia. Okay, so and then what happen when the power factor is negative? Okay, negative, the lagging. Okay, lagging unity, anything power factor. So IA, so dia ada some angle. So ni IA sama lah dekat sini. So ni IA times with R. Okay, and then this is 90 degree. Okay, kita tegakkan je, and then kita connect everything lah. Okay, so still we can see that the EA is much bigger than the V phase. Okay, so V phase is less than the EA. Okay, so then what happen when the power factor is leading? So power factor is leading, we can see over here the V phase is more than the EA. Okay, so I really hope that everybody know how to draw this power factor. Okay, so any question? Until now ada question tak? Hello. Okay. So now the subtopic we will cover the power and torque in the synchronous generator. Okay, as we know that generator convert mechanical to the electrical power. So the input for mechanical power, maybe the turbine, the hydro, the diesel engine dan sebagainya lah. Okay, and then there are three important terms. Which one? The input power. Okay, the input power, and then the losses, and then the output power. Okay, so the input power actually is the equation is P in to the equal to T apply. So apply, torque apply. Kena ingat apply times dengan omega M become P in. Okay, and then the internal converted mechanical to electrical power. So this is the equation lah, the conversion. This is the torque induced. Kena ingat So this is the induced torque. So this is the applied torque. So it's a bit different Okay, so jangan salah faham kat sini. So you boleh tercicir macam ni. Kau boleh tercicir, boleh terbabas kalau you salah Ni P con. Okay, converted Okay, where the Y here actually the angle between EA and also IA. So sometimes dia tak guna ni, sometimes dia guna, I think dalam buku dia guna simbol apa nama dia, saya pun tak pasti nama dia sebut. Tapi angle dia bentuk macam ni macam ni. Okay, ni kat sini dia guna ni. So boleh juga dia guna bentuk ni Okay, so kena ingat lah. Okay, yang penting you kena tahu ni je, the angle between EA and IA. Okay, tadi kita dah tengok phasor diagram, kita ada V phase. Okay, kita ada IA. Ni kita ada EA kan. So ni angle ni. Ni angle ni. So either dia Y, aku pun salah tulis. Ataupun dia guna simbol ni lah. Okay, so yeah, normal power mesti dia ada losses. Okay, so from input to output dia akan ada proses loss. Okay, so first is the stray losses, and then the friction winding yang losses, and then there is a core losses, and then the copper losses. Okay, so the equation for P out actually is the this one P out equal to Vt cos theta. Vt IL is equal to theta. So IL ni tengok sama ada IL dengan IA tu macam mana relationship dia. Tu kena ingat So same goes to here So this is T apply. Okay, T apply. Okay, input is T torque apply times dengan speed apa dia panggil ni, angular velocity. Okay, so dah loss Okay, so copper losses. Okay, copper losses kenapa dia darab 3 ni? Sebab dia 3 phase sebab dia 3 phase. Okay, so this is IA not IL. So kena ingat tu semua So ni opposite flow compared to the induction, because dia lah induction motor tu dia motor, yang ni the generator, of course dia akan terbalik Okay, so this is the output. Okay, kita dah tengok tadi kat sini. So the real electric output power, and this is in line, and this is the equation for the phase. Okay, so you boleh try you try conversion tadi tu. Kalau if the Y connected and also the delta connected tu kan, you try, you akan dapat equation yang sama Okay, the difference is only the relationship Vt and V phase, and also the IA and juga IL. So what is the relation? So you try change dia punya relation tu, you kan dapat. Okay, and this is the reactive power output. Okay, biasanya ni kita kurang pakai lah. Okay, in real situation the resistance in the armature or the stator can be ignored because the stator reactance is very high. Okay, so since the resistance is very high, so the RA is very low, so we can ignore the RA. So what happens when we ignore the RA? So once we ignore RA, everything will be simplified. Okay, everything, the calculation will be simplified. Okay, a simplified phasor diagram can be drawn. Okay, so this is the synchronous reactance. Okay, so this is the phasor diagram tadi kan. So sepatutnya ada IA kan kat sini. So IA ada kat sini. Dia macam ni kan sepatutnya. Tapi bila kita buang dia R, dia akan simplify. Okay, so kalau ada pun dia akan kecil je lah. Okay, you bayangkan kalau dia darab I, mungkin dia kecil je kat sini. Okay, efek dia tu boleh ignore je efek dia. So therefore dia boleh buang lah. So once dia dah buang, dia akan dapat calculation yang lebih mudah. Okay, you tengok sini ni mungkin dah banyak sangat. So ni EA, ni V phase, ni JXS IA. Okay, so dia cuba buat rectangle, triangle, perfect triangle. Okay, dia buat tiga segi yang 90 degree kan. Okay, dia buat guna trigo. Okay, katakan ABC kan. Okay, so yang C ni, untuk bahagian yang C ni, okay, bahagian yang C ni macam mana kita nak calculate dia? So kita boleh calculate menggunakan trigo. Okay, so ini angle yang bahagian IA ni sama dengan angle di sini. Okay, oh tadi saya silap patutnya yang alpha tu kat sini, yang ni kat sini je. Okay, saya silap. So yang ni tak sama silap. Alamak, tak boleh back. So dia tak sama dengan yang ni So saya silap. Tak maaf. So kemudian dia just gunakan trigo lah kat sini untuk dapatkan ni. So ni mana datang ni? Siapa boleh beritahu? Ada tak yang boleh tolong? So kalau dia gunakan sini kan, dia nak cari dari sini. So saya tak hafal. Okay, so saya tak hafal. So sin, gunakan sin simbol ni. Okay, saya tak hafal. So sini adalah CD kan. CD hafal adalah EA. Okay, so CD equal to EA sin simbol ni, delta ke apa ni. Okay, so ini satu. So yang kedua adalah XS IA cos theta ni. So digunakan cos theta. So cos theta kat sini lah. Okay, kalau saya hafal. Okay, cos theta equal to CD dengan XS IA. Okay, so CD equal to XS IA cos theta. Okay, so bila dia samakan, so CD ni samalah dengan ni kan, ada dua. Okay, so dia samakan. So dia samakan kat sini. Okay, so therefore dia akan dapat line. Sebenarnya dia bukanlah nak calculate panjang ni, sebenarnya dia nakkan relationship. Okay, dia nak relationship ni sebenarnya. Okay, so dapatlah relationship yang ada kat sini. Okay, okay, bila dia dah samakan, tapi dia susun balik. Tapi perasan betul tu kan, dia tak susun sama macam ni. Dia tak susun sama exactly macam ni. Tapi dia susun macam ni. Okay, kenapa dia susun macam ni? Sebab tadi power tadi tu lah. P tadi tu. Mana P? Sebab P out ni. Sebab V phase. Ni V out equal to VT IL cos theta. Okay, so kalau Y connected, so IL equal to IA. Okay, IL equal to IA kan, kalau Y connected. So dia boleh gantikan terus yang ni, so dalam ni lah, ke dalam dua ni. Okay, lama gila, senang. Okay, so dia gantikan, dia dapatlah equation yang power yang selebihnya lah. Okay, okay, so and then since dia ada ada sin ni, so bila dia 90 degree, so sin 90 degree become 1. So bila become 1, dia akan jadi maximum lah. Okay, so this is the magnitude, the calculation of the magnitude when the delta tu equal to 90 degree. Okay, So the static stability limit, so biasa normally full load the angle is between 15 to 20 okay, for the real machine. Okay, so this is the induced calculation, the equation for the induced. So this one is derived from the P conversion. So you boleh tengok balik lah kat belakang slide yang sebelum ni. So you just rearrange je. Sebenarnya you rearrange je, you akan dapat semula lah. Okay, you akan dapat semula equation tersebut. Okay, so I think that's all for today's punya explanation lah. Okay, so if you have any question, so you can ask me. So before that, I really hope that you can watch the video that I include in the slide. Okay, please watch the video in the slide so that you can get more understanding, and please do read the book that I shared to you. So this explanation you can get more. Okay, and do some exercise for this whatever we study today. Okay, so ya, baru 1 jam setengah. So kita ada lagi 1 jam setengah lagi sebenarnya. Okay, so the other time atau balance time ni you boleh continue to read, okay, to gain more understanding and also do the project. Okay, so any question? So please, I open the floor.
Doktor, maaf ganggu, nak tanya pasal projek.
Okay.
Doktor ada tak macam link untuk refer buat Excel tu? Sebab saya try cari partner saya try cari dalam YouTube, tak jumpa. Maybe tak sama dengan apa yang diminta.
Oh, actually Excel tu kita bukanlah nak suruh awak buat apa pun. Kita just nak awak buat macam mana tulis tangan, macam mana you calculate manual, tapi you masukkan dalam Excel tu, so that bila you tukar, kan saya suruh buat range kan, ada range, betul?
Betul.
Bila saya tukar range tu, saya akan dapat jawapan yang sama kalau saya kira manual.
Okay.
It's just a normal calculation je. Tak ada perlu equation, tak perlu equation, tak perlu satu macam programming ataupun algorithm, no, tak perlu pun. Faham tak?
Faham Doktor.
Dia bukan satu bentuk macam bentuk yang bersusah payah you kena buat, tidak. Okay, you just a normal calculation tapi you buat dalam bentuk Excel. So bila saya tukar parameter tu, contohnya parameter awak dengan parameter group lain kan, so group lain ada calculation, you buat ada calculation. So your punya Excel, saya gunakan you punya Excel, tapi saya masukkan parameter group lain. So bila saya masukkan parameter group lain, dapat tak result sama dengan group lain tu punya jawapan? Kalau sama, maksudnya you punya calculation tu sama, betul lah. Faham tak?
Faham Doktor.
So okay. Semua group akan menghasilkan Excel yang kurang lebih sama je. Okay, so tapi kita nak tengok lah. So bagi saya, kalau group yang advance nak makan lebih, so dia akan buat je range daripada semua sekali tu. So dia punya sistem tu complete. Tu kalau saya lah, saya akan buat macam tu lah. Okay?
Doktor?
Ya, saya.
Doktor, hari ni ada quiz ke doktor? Biasanya ada quiz kan?
Nak ke?
Tak ada, just tanya je. Kalau tak ada, tak apa doktor.
Okay, Nyai. I think saya dah bagi quiz kan last week.
Dah
Okay, so, kita pun baru masuk bab ni. So bila kita masuk bab ni, biasanya at the second week baru dia akan ada quiz. So setiap bab mesti ada quiz. Okay? Itu syarat dia. Setiap bab mesti ada quiz. Okay? So sekarang I think quiz induction motor saya dah bagi kan? Tak apalah, nanti boleh tengok balik.
Sudah.